following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Now, as the light passes from medium 1 to medium 2, it bends away from the normal. Recall that tells us that the index of refraction for medium 1 is greater than the index of refraction for medium 2. Now, if we keep increasing the incidence angle, what's going to end up occurring is that the refracted angle keeps increasing as well. Now, once the angle of incidence increases to a point where the refracted angle is 90 degrees, right, then the refracted ray is directly along the interface. And at this point, the incident angle is known as the critical angle. Now, if we increase the incident angle past the point of the critical angle here, then we're going to, we'll have what is known as total internal reflection. Meaning, past the critical angle, there is no refracted ray. Furthermore, all the energy from the incident light ray is reflected. Therefore, this light remains now inside medium 1. Let's solidify our point with figure 38 once again. Now, for angles of incidence that beyond the critical angle, such as light ray 5, 6, or 7, there's no refracted ray. And all the light is reflected at the boundary surface. Let's sum up the conditions needed for total internal reflection and the critical angle. Take note, as this is important. Coming back up here now to figure 37, right? Firstly, total internal reflection only occurs when a ray in medium 1 is incident on a second medium whose index of refraction is smaller. That tells us that the light is traveling slower in the initial medium relative to the medium it's entering. Moreover, the critical angle is defined when the angle of refraction is 90 degrees to the normal. And lastly, a total internal reflection occurs when the angle of incidence is larger than the critical angle. Okay, now if we like, we can see an example here in figure 39. Here we see total internal reflection taking place. Light from the laser coming from the side of the tank is reflected at the air-water interface, and there's no refracted ray. Now, what if we want to find the value of the critical angle? How can we do so? Well, we can do so using Snell's law. Let's take a look at that on the next slide. We'll begin up here with Snell's law. Now, when the critical angle is reached, the refracted ray is parallel to the surface, right? And the refracted angle is going to be 90 degrees.